morning to all. Myself Shreya and I am again here with a new topic named water. So let's start. Firstly, what is water? Let me write down for you. What is water? So you know that water is a chemical. And we also know that all the things around us are made up of molecules, and that molecule is also made up of the atoms. Let's write on this. So the water, take that this is the water molecule. This is the water molecule. And this water molecule is made up of 3 atoms. Which are the atoms? The 2 atoms of water is of hydrogen and one of them is of oxygen. That means there are 2 hydrogen atoms and 1 oxygen atom. See what has I written? It is H2O. H2O. The chemical term of water. Chemical term of water is H2O. That's what scientists call this water, H2O. So let's study about the water's importance. That was what is water. So let's study about what is the importance of water. The importance of water. So let's start with this. So you know that water is so important for us, and in its domestic use there are so many, and then the agriculture and the industrial. So what if I compare this domestic and that agriculture or industrial uses of water? Then the domestic uses of water, and then the agriculture. The agriculture uses water also. So if I will look at this and compare this, so take that this is the circle of water, or this is the water uses, the total uses of water, and then if I will divide this out for you, so it will look like this. Agriculture uses 70% of water, then industries uses 20% to 22% of water, to 22% of water. And then talking about this, the domestic uses is 8% to 10% of water. So the domestic uses, take that round offing, the domestic uses 10% of water, then the industrial uses 20% of water, and the agriculture uses 70% of water. And what if I ask you, how is water important for our body? So let's study about that also. So if I will talk you about that, so everyone will tell that the water, our body is made up of water, therefore it is important for us, and it is made up of 70% of water. Now that is wrong. Our body is made up of 55% to 60% of water. It is the exact answer. If you will search it in the Google or anywhere, it is the exact one. 55% to 60% is the exact one of our body's percentage of water. So if I will define it so specifically, the brain and the heart is made up of 75% of water Then our lungs is made up of 83% of water, and then our bones is made up of 31% of water. You can note down this. I think it is visible to you. Brain and heart is made up of 75% of water. Lungs is made up of 83% of water. And this bones is made up of 31% of water. So let's move ahead. And now I think you know that importance of water and the uses of water. So let's move to the other topic or other subtopic of water. So the other subtopic of water is the distribution of water. What do you mean by distribution of water? Water is, I am just dividing it. That thing that, you know that, think that our earth is made up of 3/4 of water. You know that our earth is made up of 3/4. It is 3/4 of water. So there is the earth's surface is covered by the 3/4 of water, and take that this is the total water of the earth, and the 97% of water, this 97% of water is unusable, or it is salty water. It's salt water. It is 97 of them, and this remaining 3% of water is fresh water. It is fresh water. So it is the fresh water. The percent of fresh water is 3%. And if I will take this 3% of water, so this is what the 3% of the fresh water. And what if I tell you that in this fresh waters, this is the total fresh water, and this in this also the 79% of water is also present in the ice caps and glaciers. You know the meaning of glaciers? The glaciers are the frozen water on the top of the mountains. It is generally found in the top of the mountains. And why does we can't use this? Because the ice caps, they are so far from us, and they are in the North Pole and the South Pole, and that ice caps cannot be melted. We can't hammer it, or we can't melt it. It takes the time of 1 million years and so million of years. So it takes so many time, and therefore we can't use this ice caps and glaciers also takes so much time for melting. And this 20% of water is groundwater. Now what if I tell you that this is also unusable? How this is unusable? Because the 20% of the fresh water is so deep that we can't dug into that, and we can't use that water. It is so deep. So that means this left us only 1% of water, which is usable to us. This only 1% of water is usable to us. that is just 1/10 of Earth water. Now do you understand? Only 1/10 of Earth's water is usable, and we have to feed all of our population. Only 1/10 of Earth's water is usable. Now you can think there is a scarcity of water. So let's understand the states of water or the properties of water. That's why I recommend you to save water for the future, because water is scarce. So let's study about the states of water. States of water. So you know that water exists on Earth in the three forms, which are water, the liquid form. The liquid form of water is the water, we say it as water, and the gaseous form of water is water vapor, and then the solid form of water is ice. You know that? So water, you can see I have here some water. So you can see this is a liquid water. We all know that this liquid water, and you know that the water vapor is present in all around us, and you know this ice, the solid form of water. It is so cold. You know that water freezes at 0 degrees Celsius. This is the ice, the solid form of water. You can see this. It is a solid, like this board. It is a solid. I can't press it. And you know the liquid form. You know the liquid properties in the gaseous. So let's study how can we convert this states of water. So you know that if I will heat water, if I will add heat to this water, the liquid form of water, so it will turn into water vapor. And when I cool this water vapor, I will again get the water or the liquid. And what if I cool this water? So I will get this ice. Do you understand that? If I heat this water or add heat to this water or liquid, I will get the gaseous form of water. And if I will again cool this water, I will get the water vapor. Sorry, water, liquid form of water. And then if I take this liquid form again, the water liquid form again, and then cool it or cool it, I will get this ice or the solid form of water. So that was how we can change. Now if I ask the question, why does it happen? Why will it not happen that if I will cool this water liquid and it gets to the gaseous form? That's because, let me explain you. That's because, take that, here I have the solid, that the ice it is, then the liquid form of water, and then the gaseous form of your water. I'm taking this to represent the gaseous form of water. Gaseous, and it is the liquid. And it is the solid. So, you know that in the solid, the molecules are so they are tightly packed. They are so close to each other. are so close, therefore we can't press it, and they has a so strong force. And in the liquid, the molecules are a little far away as compared to the solid. So they are a little far. And in the gaseous, they are so far from us. They are so far from each other. So now, if I will heat any of the molecules, it start getting far from each other. If I will add heat to these molecules, they are so tightly packed in the solid. So if I will heat or add heat to this, the molecules start getting far from each other. This start getting far, and therefore it converts into liquid, because it is far from the the molecules of liquid are so far from the as compared as the solid. And if I will heat this liquid, I will get the gaseous form, gas form of the matter, so of the water. So if I will add heat to the molecules start getting far from each other, therefore it converts into water, converts into liquid. And if I will again heat it up, the molecules start getting far and they convert into the gaseous form. And what if I cool this? So if I cool this, you know that if I am heating the molecules, they are getting far, and if I cool that, they start getting closer to each other. So they get close here, and then again if I will cool this liquid also, so it will get into the solid form. That means if I will cool, on cooling, the forces between the molecules, start getting closer, And if I will heat it, on heating, what happens that the forces between the molecules start getting increase, and here what happens, the opposite of that, on heating the forces start decreasing. Or that means that the forces start getting weak, here, and here it starts getting stronger. So now I think I think that you are sure about this, that when I cool the molecules, or when I cool the water, so it starts getting stronger, the molecules start getting stronger, and it forms the gaseous, take about the gas molecule, and they are so far from them, they are so far from each other, and if I cool that, the molecules start getting closer, and it forms the water. And then if I again cool this, they also start getting closer, and they form the solid. Like this, if I heat that, the forces between the molecules get starting weak. They start weakening up, and you can see the molecules get far from them, and it forms. This was the whole why when we heat the water, so it turns in that, and when we cool the water, it turns that. So I think you should note down this also. So let me erase this. study about the properties of water. The properties of water. So first I tell you that when I heat the water, it turns into the water vapor. So when the water is heated on heating, it turns into water vapor. And this process of this is called evaporation. Evaporation. It is called evaporation. So the evaporation is a process. Evaporation. Let me change my marker. So the evaporation it is a process, or it is a process of changing liquid water or water, not water, liquid to, it is a process of changing liquid into gaseous form. So evaporation means the process of changing liquid into the gaseous form. I am not talking about the water only, I am talking about all the liquids like the oil, all the other things. So the evaporation is the process of changing liquid into the gaseous form. So let's study about the condensation also. So let's do the experiment for understanding this condensation. Here I have the ice and here I have the water. I have a glass. Now what I am going to do, I am going to put this ice in this water, in this glass. So now I had put the ice in the glass, in the empty glass, and let's observe at the last of the video. You will see some experiment or something amazing in this. Let me put it here without touching it. It is now put it here. So let's study about the condensation. So you know that if I had heated this water, it turns into water vapor. And what if I cool this water? It will turn into the water. And now this process, on the heating, it is called the evaporation. And when I cool the water vapor and it turns into water, it is called condensation. Condensation. So when I cool the water vapor or the change of water vapor, or not a vapor, or okay, take that water vapor to or into liquid form. It is called condensation. Condensation. So that was the evaporation and the condensation. So now I think that okay, let's see this glass. See this glass, and you can see that here around this glass there are, see here, there is water droplets. Oh, see, there are water droplets here. See, this water droplets, they are so tiny. And if I will touch this out for you, you can see that you can see this. Why are there the water droplets? Why are there the water droplets? Because the glass was dry from outside. So how can there be water droplets? So let's study about that. This is because of the process of condensation. That is because the water vapor which is present in our air or in our surrounding is touching on this surface, touching on this icy glass. This glass is cooled because of the ice, and the water vapor touch on it, it starts cooling down. And when it starts cooling down, it forms the water. So it forms the so tiny water droplets, and you can see this water droplets. This is called condensation. So I think that I should cover all the subtopics in the next video. And for now, thank you and have a cheerful day ahead.